Okay, so next thing we're going to go through is going to be a vernier scale. Okay, so this right here that you have in front of you on your desk is what we refer to as a vernier caliper. And the caliper part of it just means that there's two different sets of teeth that are going to come together. Okay, a very basic type outside caliper. This is the most basic of outside caliper here. Okay, so again, I can adjust those further apart or closer together depending on what I want to measure with that. So that's an outside caliper. This is an indirect reading tool, and we'll cover it a little later. This is a direct reading tool, and it's going to give us a measurement off of it. Again, fairly accurate. Okay, if you have a good vernier scale on them, these will allow you to read down to 0.05 millimeters on this one, and typically on a good vernier scale, you'll be able to read down to within 1/1000th of an inch with a if there's an imperial scale on there, a 25 division scale on there. Okay. This has a 1/128 scale on it, but the process behind reading them is all the same, so it doesn't really matter. And I think all of yours have a 1/128 scale. Kind of a weird measurement, right? But if you think about it, we went 16ths, 32nds, 64ths. The next smallest division would be 1/128. So that's what these are capable of measuring anyways. Okay. So again, just like I mentioned yesterday, what this allows us to do is read this down to within that small measurement. Okay. Yesterday we came across a bit of an issue, okay, where if you remember when we were reading on the micrometers, we had our index line along there. Okay, our thimble came down across here and here, and we had a situation where we had, right, those are our lines, we had a line split over top, and we weren't sure exactly where in the middle that was. So we guessed, right? And we thought it was somewhere in 0.5, you said 0.6, somebody else said 0.4, right? And all our visuals are a little bit different. So what a vernier scale is going to do is it's going to magnify in some magical way down exactly how many divisions. We can decide how many divisions we want to put it into, and it's going to align up to a different scale, and it's going to tell us exactly how far through we are. Okay, so where do we have vernier scales? Well, we're going to have them on verns or vernier calipers, just like this. Okay, and this is what we'll kind of focus on today. Okay, but also we have them on, I'm just going to zoom in here for you. We'll have them on a micrometer, just like I showed you. So this right over here, you can see there's our main line. You'll see this is the vernier scale up the top. So back onto the sleeve up the top is another scale that we will read back off the thimble onto for this particular one. But that's where we will see a vernier scale. Okay. You'll also notice this one here is a little bit different than what we were looking at yesterday. But again, we'll go through that a little later on in this lesson. Okay. Here's a vernier scale for a bevel protractor. So what this does is this has the capability of measuring down to within 5 minutes of a degree, okay, or 5/60ths of a degree is what it's capable of measuring down into. Excuse me. So another prime example of where we've come across a vernier scale. Okay. So the concept behind them isn't just on verniers. Has anybody ever seen one of these before? Yeah? Do you know what it is?
I've only ever used it for scribing lines.
Scribing parallel lines. So you're absolutely right. We set this down here, and this is a scribe out here, and I can scribe very accurate lines all the way up. But you'll notice up here, okay, was the one you used, was it a vernier scale on it?
I can't recall.
Can't recall? Okay, that's okay.
I feel like it was actually.
I'll get this, see if I can get this in the camera just so you can see it. Again, we have metric on one side, and we have 1/128 again on this scale on the other side. Okay, this is our mean scale up the center, this is our vernier scale on each side, and that's going to be the kind of the magical thing that lines up and tells us exactly how far we are through. Okay, so that's kind of our intro to it. That's why we need to know how to use them, right? There's a lot of different tools we're going to be exposed to and have to kind of utilize this concept for. So, Aiden, you said you've kind of used one, maybe had a vernier scale on it. Do you remember how to use a vernier scale?
I can fiddle with it. I'll remember.
You'll remember. You'll be able to teach yourself again as you fiddle around with through it. Anybody else ever used a vernier scale before? Again, we're about shop class again. Yeah. Do you remember how to do it? Think so? Okay, that's good. That's a good start. Anybody else?
So I use them, but I never read them. It was just for like when I reload bullets for hunting and stuff.
Oh, okay.
You put them in, and I never understood how to read them, so I just made sure that they're all the same. They all ended the same.
So you turned it into one of those calipers, right? That just measures it, and you said, yeah, this is yours. Got somebody else to verify it. Yeah. As long as they're all the same, then we're happy.
Yeah.
Right? Kind of use it as a gauge, and that's great. That's all that any measuring tool really is. Anybody else use a vernier? You remember how to use it?
No, we just use the digital readout.
Digital readout. So the concept was there. The tool was the same, but the way you read it was digital. Okay. Gavin, let me just see that one for a sec. So this is another version of those, right? A dial on it.
Those are my favorite.
These are my favorite as well. I like them better than digital even, because you can really see where exactly you're hitting the low or the big size. Okay. So those are all different variations. Again, we're kind of, it's kind of a little bit of a glimmer of how we do it. Okay. What I'm going to show you today as well is how it works. Okay? Not just how to read it, but how it works. So hopefully then, if you understand how it works, we can carry that on into all these other tools, okay, and reteach ourselves in the future. Like I said yesterday, it could be a couple of years by the time you ever have to utilize one of these again. Okay. So keep that in mind as we go. Okay. So just like yesterday, we're going to go through and again, at this point, we're just going to focus on some vernier calipers, but it's going to kind of, because this is where we're going to learn how to read them on after we design it. So we're going to go through some terminology on this one. So as we go through this, and again, I'll just throw this up here so you can see same sort of thing. We'll go through it just like we did yesterday. So again, the whole thing here is what we refer to as a vernier caliper. Again, the reason we're doing this is just so as I'm talking about it, we understand what components I'm discussing. So, and again, compare it back to the one you have on your desk if you need to. But jaws 1 and 1, those are what we refer to as the outside jaws. Okay, and what that means is that we would be able to we'd be able to measure the outside of something with that. Okay. Just zoom in a bit more here. Okay, that's a little better. So again, if I was measuring something, I would be measuring in and around here. Okay? So that's the outside jaws. What did the number 2s do? Does anybody remember? Remember for measuring an inside diameter? So again, our workpiece would be something like that. Okay. Now this main part, number 4, And again, well, it's kind of number 4. Number 4 is actually referring to the scale that's on there. But this whole piece right down the center here is what we can refer to as kind of the beam of our vernier calipers as well. Everything slides along that beam. Okay? So you can drop that in there. Number 5 is our main scale, our main imperial scale. Okay? And if you look at this one, it's divided into how many pieces? 16 pieces. Okay, so it's in 1/16 of an inch. Okay? When we go to a different style, okay, our main scale can change at times, and we'll review that as we practice through. Okay? The concept of how it works is the same, it's just the way we read it is going to change. Number 4 is our metric scale, so lots of times we're dual measuring capabilities on it, both imperial and metric. Okay. Number 3, does anybody know what number 3 is for? It's the depth. Absolutely. So, and we can slide it down, we can measure the depth of a hole very easily, the depth of a groove very easily. It can be very handy for that. Okay. Now, number 7 and number 6, those are both our vernier scales, and again on the respective sides. The top one and this one is a vernier scale for the imperial side of things. The bottom one is a metric scale, or metric vernier scale. Okay, again, in both of those, it tells us how much, what increment or the discrimination of this. Okay? So the imperial scale is capable, has a discrimination of 1/128th. Okay? The metric scale has a discrimination of 1/20th on this particular one. Okay? What's 1/20th of a millimeter equal? 1 divided by 20? 0. So on the bottom side, we're capable of measuring down to 0.05 millimeters. Okay? That's the discrimination of this vernier scale. What's the discrimination of our upper scale?
1/128.
How many thousandths of an inch is up? How do I figure that out? 1 divided by 128. Okay? What does that equal? 0.0078. So roughly 8 thousandths of an inch is the discrimination of this particular measuring tool, which is fairly accurate, right? We can get them to measure down to within 1/1000th of an inch depending on what kind of scale we put up here, or the divisions that we put on there. Okay? At this point though, we've kind of labeled all the different components. Again, number 1, the outside jaws, inside jaws, depth gauge. So that's where we're actually going to be doing the measuring from. From here to there. Okay? On the outside, or on the inside of an object, on the outside of an object here. Then we have our main beam that has our main scales on it. Again, the process to reading this is in a sense similar to our micrometer, in that we read the main scale first, and then we work our way. Okay. Then we have our vernier scales, which is going to tell us, and when we read these scales, we read where the 0 is. Okay. That's where we read onto the main scale anyways. Okay. And then whichever one of these lines up is what's going to work for us, is what we add to it. Okay. But I'm going to show you guys why a vernier scale works, or how it actually works, how they designed it to work. Okay. So, any questions at this point? Okay, we kind of know where we're going to be, what we're going to be doing with it. We're going to be measuring something, we get between lines, and we need to know how far between the lines we're going to measure. Okay. So let's make a vernier, a sample vernier scale. So what I'm going to do is I'm going to lay out we're going to actually make a vernier scale first. So a little bit large scale one on 2 pieces of paper. Okay. So I'm going to hand out some paper and some rulers, and then I'm going to get you to follow along, and we're going to make our own. Okay, so I'm going to give you 2 pieces each. One is going to be our main scale, and one's going to be our vernier scale. Everybody have a pencil? Everybody using a pencil? Okay, so what we're going to do is on one piece of paper here, I'll zoom out and I'm going to do it with you, okay? So let's take our rule, and right in the middle of this page, somewhere in about here, maybe even off to one side we can do it, we're just going to draw a line straight down. Zoom out a little bit more. Okay. So now what we're going to do, we're going to come up here somewhere, you know, just a little ways down from the top, and I'm going to put a line across right here. Doesn't need to be too, I'm going to make mine a little thick just so you can see it up here on the screen. Okay. So that is going to be, let's say, 0. Okay. Now on our rule, okay, what I'm going to do is I'm going to look for the 1-inch spacing one. Okay. So right here you'll see on this side of my, I'm spaced out in 1-inch increments. Right over here it says 1 on that side of my ruler. Everybody find that one? Okay. So what we're going to do is we're going to set this down, and right on my mark at 1 inch, okay, and I'm going to come down here and I'm going to put marks at each individual inch, and I want to get at least, say, 8 of them on there. You can go right to the bottom of the page. Fit as many on it as you can. Yeah, now what I'm going to do is I'm going to come over, I'm just going to extend those across a bit here. So really what I'm doing is I'm just making a bit of a ruler right now, okay, with 1-inch increments on it, okay? Give you guys a sec. Again, close is going to be close enough for this, right? It's going to get us the idea of what we have to do. So on the left side of that line, as we're going down, we're going to label this. 1, 2, 3, 4, 5, 6, 7, 8. I fit 9 on mine anyways. Okay. Now this scale that we're building, it's going to show us the purpose of it. It's not going to be a the magical scale, but well, in one sense it's kind of magical. But you'll kind of see exactly what's going on as we get there. Okay. So what I'm going to do now is I'm going to fold this over right on that line, just so I just have basically just kind of like the edge of a rule here. Okay, so I folded that over, so I have my numbers out and I have my rule right along there. So everybody's got that right there? Something like this. Okay. So what we're going to do now, okay, we're just going to set that piece off to the side, and now what we're going to do is we're going to create our vernier scale. Okay. So again, we're going to start with a line top to bottom. Just like so. Again, we're going to come up here. We can start it, about the same spot as our 0 was before, right here. Okay. And we can label that one as 0. So you'll see here, right, I got my line and I got this. So, and actually what we're going to do, let's label these two right now. So this is my main scale. And this one over here is my vernier scale. So the idea is that, again, if I jump back to my caliper here, again, I'm measuring something. I'm going to measure off my main scale first, and then there will be something that lines up, a magical number that lines up on my vernier scale that tells me exactly how far in between it is. So that's what we're designing, so kind of keep that in mind. So this is going to be my main scale, and my vernier scale would theoretically slide along right next to it or beside it, and you see where my 0 is reading, it's going to read off of that main scale as I go. Does that make sense? So what we're going to do is I'm going to say, okay, if I slide that vernier scale along to somewhere about there, how far between the 0 and the 1 am I? So what I'm going to do is I'm going to find out how many 1/8 of an inch I am between that. Okay? Using a vernier scale, not using another measuring instrument. Okay? So, and it's kind of cool once you see it actually work. And the concept behind how a vernier scale works is what we do, and like I said, we're going to split that into 1/8. Okay? So what I'm going to do is I'm going to come down to, so 1, 2, 3, 4, 5, 6, 7, 8, right? We're at the 8 spot here. Okay? What I'm going to do is I'm going to go 1 less to 7, and I'm going to put a mark right here, right there. Okay? So the way a vernier scale it works is that we have the same amount of spaces taking up 1 less space of our main scale. So the same amount of divisions, 8 divisions, and what we're going to do is we're going to take up 7 positions on it. Okay? So 7 positions on our main scale are going to be taken up by 8 divisions over here. Okay? That's the theory behind a vernier scale. So let's do that now. So what we need to do is we're just going to set our main scale off to the side now. Okay? And I'm going to roll my I'm going to roll my rule around until I'm at the 16 here. Okay? I wish we had 8s on and 8 on here, but we don't. actually the eighth, we do have an eighth. There we go. I'm gonna roll it around to the 1/8 mark. No, that's confusing. Let's go to the 16. Let's go back to the 16. So what I'm gonna do here is I'm gonna line up my 16 and my 0 there, and you'll see that it lines up 0 all the way down to 7. Anybody want me to zoom that in? Okay, and my other mark is down here on the 7. Everybody sees that? Okay, so if I want to divide 7 inches into 8 equal parts, I take 7 and I divide it by 8. What does that equal? 7/8, right? So that's what this tells me, is each of these individual components is going to be, or the scale on this side, because I took 8 whole units over here and I divided into 7. I keep 8 units, but I wanted it covering 7 inches. So I take 7 inches and I divide it by 8. So in along here, I'm going to put a mark at 7/8, and I'm going to come down, and then it's going to be 14/8, right? 21/8 if you want it to count that way, or each time it just jumps by an eighth up through that inch. Okay, so let's do that. And if you're not following, just I'll try and walk you through it. So I'm going to start this first one out at right there at 7/8, and I just need to put a mark there. Okay. The next one is going to be 1 3/4. What's the next one going to be at? 2 5/8. 3 1/2. 4 3/8. 5 1/4. 6 1/8. And the next one's right at 7. So that worked out perfectly. Do you want me to read those out again? Or is everybody kind of seeing how it jumps just back an eighth each time? Skip one there. Okay, that's okay. So what we can do with that now is let's label those. 1, 2, 3, 4, 5, 6, 7, 8. So we still have 8 divisions. They're just taking up 7 spaces on the main scale. Okay? So what we're going to do now is we're going to put this over here. Okay? And this is the magic of the main scale. The main scale on the vernier scale. So you'll see here at 0, 0 and 0 line up, and 8 and the 7 line up. Okay, and that's supposed to be the case. The 0 and the final thing on our vernier scale should line up. If they don't, then we did something wrong. Everybody has that right next to there? Does anybody need an extra minute here to get those numbers drawn on there? Everybody's good? So, let's slide this vernier scale along underneath our main scale here. Okay? Let's pick a spot. And if you watch this, what it's going to tell is exactly how many eighths I am from 1 inch to 2 inch. Okay, so you see this? I slide down right there. You see where my 0 is? lined up right here. That is exactly 1/8 of the way through this space because the 1 lines up. Everybody see that? Slide it a little further. Slide it somewhere in the middle. Right? Not exactly in the middle. Doesn't really matter where you slide it. But what you'll notice is it doesn't matter where I move it. Where am I now? How far past the 0 am I? 3/8. The 3 lines up. Cool, eh? Magical. It's worth waking up this morning. Okay? So that concept of taking our vernier scale, and they're all going to be slightly different, but the idea works the same. So what they've done is they've taken a specific number of spaces on our main scale, and we divided it up onto this scale. So if I wanted to know how many 1/1000ths of an inch were on here, okay, I could split this into 1,000 pieces. They cover 999 of those other ones, and only one will line up perfectly. The one thing I want you to notice here, the 2 and the 4 line up are pretty close, but you'll see that they are both hugging the 3. So a lot of times this is another prime time where we need a magnifying glass to really truly read these vernier scales very well. Which line is actually lining up? Because you can usually narrow it down to 3 lines, but you're not quite sure which one it is, so magnifying glass can help with that as well. Any questions with that? Slide it along again, a little further. Now the problem with this scale, okay, is that as soon as I get down to about like 1 or 2 inches, this end's going to be off of my main scale, so I would need to extend my main scale further for this to work, okay? But really, if my main scale, if I had a tape measure out here now, okay, I could slide this scale along because I laid it out, and it would work out just the same for me. Should I prove it? I'll zoom in here. Let's see if we can prove it. Again, it's only going to measure 1/8 of an inch for me. But if I was coming along here, okay, slide that down to there. 1/8, look at the 1 lines up with the 13. Okay, come down to 1/4 of an inch right there. The 2 lines up with the 14. See how that works? Let's pick a spot out here in the middle. 5 lines up with the 17. Okay, so that vernier scale is an 1/8 inch vernier scale, so I could put that over here. 1/8 has a 1/8 discrepancy of an inch because that's how I built it. That's how I set it up. Or discrimination, discrimination, whatever you want to call it. Any questions on that? Kind of cool? Do you think that would help you in being able to figure out how to read one now? Okay, so let's challenge ourselves now. Okay, what I'm going to do, and Gavin, you might need to turn around and look at theirs, or I'll pull this up on the board so everybody can see it. It doesn't really matter. So that's kind of the idea of how a vernier scale works. Now let's see if we can practice and do a couple of readings here. Okay, so again, I'm going to just slide this open somewhere. Okay, right to about there, and I'll go through this first one, and then we'll see if we can we can figure out our way through it on our own after that. Okay. So first off, let's read on our main scale. Okay, that's what we have to read. So initially, what I have to do is I have to look at and a lot of these scales are going to be different. I showed you. Some are for micrometers. Some are for an angular measurement. Some are for a height gauge on here. Some are going to be in 1/28. Some are going to be in 1,000ths of an inch. Some are going to be in 2,000ths of an inch. Okay? So there's a lot of different variations, and we have to be able to know how this works now. And what that will do is it will allow me to identify and teach myself how to read all the different versions of these scales that are out there. Okay? So let's look at this top one. How many divisions are there from 0 to 1 on my main scale? So 1, 2, 3, 4. to the corner, or 4, 8, 12, there's 16 divisions in there, okay? So each one of those is a 16th of an inch. Everybody happy with that? Okay? So, I have to read from the 0 down onto my main scale. I have an object down in here, right? And this is what I'm measuring right now between those two jaws. Okay. So how many 16ths am I at right now? 13 16ths. So that was 12. 13, 14 16ths I'm at. Right? My 0 is lined up past that. And what my vernier scale is going to do is it's going to tell me how far between those two lines it is. Does that make sense? Everybody following me? Okay. So, what I'm going to do is a little bit of math. I'm going to say, okay, I'm just past 14 16ths or 7/8. Okay? That's my main scale. Can I read any more accurately off that main scale? Can I read any more accurately off there? No, I can't. That's as tight as I can read. So this is as accurate on the main scale as my rule or a tape measure. Okay? Now what I have to do is say, well, how far between these two am I? Well, I need to look and see which one lines up. Which one lines up? The 3? 1, 2, 3. That lines up. The 4 is a little bit this way. The 2 is a little bit that way. Okay? So what does that mean? 3 128ths between those two. Okay? So I come up here and I say, three 128. Okay? What does that equal? 8 times 16 is 128. So I could just punch this into my calculator if I wanted. I could do it longhand, but let's do it longhand. So 8 times 16 is 128. Okay. 7 times 16 is what I do to the denominator, I have to do to the numerator. 112. Okay. So 112 plus 103. 115, 128. Cool? Everybody get that? Okay. So let's clear that off. Let's move it. We'll do another one like that, or I'll challenge you to do one. Okay? See if you can do it on your own. I'll come around and check on you. Okay. So let's slide this up here. Again, don't forget to count the main scale. So we're already at 4 inches. So that's where I'm just going to start you out there. 4 inches. Okay. Now I'm going to challenge you to tell me where we are sitting there. this measurement, you got a fractional measurement for it? So this one's not gonna be the same as that, just because right now it's different stuff, so it should be somewhere around, if I go, so it would actually be out, that's the 150. That's what it would be, okay? 4 and 3. No. So keep in mind, right, we're 4 inch. This right here is a 16th. So 4 and a 16th plus then the 3. 128. Did I do that wrong? Maybe I did that wrong. 4 point. Oh, I might have did my math wrong. Sorry. Let me redo that. Neither of us had it right.
It's hard to see which one lines up. Is it the 3 or the 4?
I'd say it's the 3.
The 3?
Yeah. Oh no, I see what you're saying. And again, it all depends. If I look from over here, then it changed, right? So yeah, you could say the 4. What did you have then for the 4? You had 12 128s. Sorry, John. Apologize.
Depends how you read it.
It does, yeah. Yeah. Is that making sense to you guys?
Yeah.
You guys want me to roll through this one again, just as a sample? Yes, please. Okay. So I'll just clear it off here. Again, on an exam, anything like that, what you'll see typically is, I would say, there would be a little arrow underneath. It'll say, so then there's no, right, photocopying is always tricky to do. It gives a little bit of discrepancy, but what we'll do, and even from now on as I do them, we'll decide as a group which one lines up, and we can go from there. So with that being known, I know that I'm at 4 point, okay? I'm past the 1/16th, so that means I'm at 4 and a 16th already, okay? And then I need to add what onto that? 4 128. Okay? So I end up with 4 and 16 times 8, 12. So I end up with 4 and 12 128. I reduce that down into lowest terms, and I end up with 4 and 330 seconds. Okay. Okay. Everybody getting that? I see one head shaking no, so again, I'm looking at where this 0 lines up. Okay? It lines up. So you see where I got the 4 and a 16th from? Right? That's that right there. So that's all I can read off my main scale, and I'm reading, this is the edge of my part. It's somewhere, so now it's somewhere between these 2 lines. Whichever one of these will tell me which one lines up with that. Whichever one lines up will tell me exactly how far between this line and this line I am. In 128, because that's what that tells me there. Okay?
Oh, that makes more sense.
Yeah.
Does that make more sense? Okay? No, and that's good. That's what it takes, is a little bit of practice. Let me clear this mess off, let's do another one. Okay, I'll just slide her in there. You get this side of the road here. I'll go through it with you this one, just to make sure everybody's getting it. So I have 2. And how many 16ths? 4, 8, 9 16ths. Everybody see that? Yeah? I'm beyond that, so I have to add some value to it. How many 128ths am I between those two lines? I'd say 5 or 6. Okay, and this is the one downfall of a vernier scale, is there is one magical point where those two are very, very close. Okay, so let's, again, on a test that they will line up, I'll put a little marker there. Let's just say it's the 5 for now. Okay, so now I have to add on 5 128ths to that. Okay, what does that equal? Again, now is when it's handy to be able to punch it into your calculator, because it'll give me and 77 128. Okay. Now, if I wanted that as a decimal, I would just take 77 and divide it by 128, and it's going to give me a decimal equivalent to that. Okay. Any questions with that? Does that kind of make sense? Again, you'll see here basically what they've done is they've taken 1, 2, 3, 4, 5, 6, 7, or sorry, 1, 2, 3, 4, 5, 6, 7, 8 pieces. And if I count it down here, if I line it up underneath, how many spaces will it take up on my main scale? Just clear out those dots. One, 2, 3, 4, 5, 6, 7 on the scale below it. Okay, so that's how it kind of works and lines it up. Okay, 8 spaces on a, and basically we just have to, as long as one of those numbers is one less than the other, then they will jump, they will line up. Okay, now let's practice on the metric side of things. Okay, let's see if we can figure that out, because it's a little bit different. Again, we're gonna have to work our way through the process of it. Okay, so I'll do one example and then we'll see if you can get it on your own. Okay, so let's set that one right there. So on the metric side of things, on this bottom side, okay, I look at my main scale. How accurate can I measure on it? Down to 1. Just on my main scale, these are just millimeters. Okay, sometimes you'll see 1/2 millimeter lines in there. Gets a little tight, little clogged up, but this one's a good one. So right here I'm at 30. What am I at? 35 millimeters. Right? Now I need to add on a value. Each one of these divisions down here is the equivalent of 0.05 millimeters. So which one lines up? Let's see, either this one or this one. Okay, so let's say it's the 2.5 one. Okay. So what that means is each one of these is 0.05. So this is 0.05, 0.1, 0.15, 0.2, 0.25. Okay? So now I need to add on plus 0.25 millimeters. 35.25. So that's it. Does that make sense? Everybody, how I did that? Okay, let's do another one together, and then I'll see if you can do it on your own. Guess you need to see everything on there. So, 110, 111, 112, 113. 13. And now which one lines up? Let's say the 8.5. Again, when I did this math down here, it just ends up to 8.5.
So much easier.
Pretty easy. Okay?
Metric's so much better.
Metric's so much better. You nailed it. Okay? Another one? Jot this one down on your paper. I want to see if you're getting it. I'll put my pointer on the one that I think lines up. Do you see where I got the pointer? Getting it? Good. Perfect. That looks better. Perfect. Metric is easy. Perfect. Perfect. Stuff. So metric is easy in this sense, right? So, yeah, that's basically how we're going to always, we read as much as we can on the main scale, and then we're going to jump up and use the vernier scale to add on to that. Okay. So, there's another example I want you to do. Did everybody bring your sheet from yesterday, your worksheet with all the measuring examples on it? Okay, can you get that out for me now? We're going to look at a few different scales on this one, or a few different examples. So this is in around, you're about halfway through, just over halfway through. We're going to go page 14 or 15, and it's going to look something like this right here. Now this, I'll give you a chance to get that out.
Probably start bringing your desk to work.
So if you can share off your neighbor if you don't have it. But what this breaks down into is it's kind of a bit of a combination of our micrometer that we went through yesterday. Okay, so it's an exploded view, right? It's zoomed in as it's scanned here. This is 0. Okay, it's always worth looking at that number, because if this was 2, then we're going to be between 2 and 3 inches. Okay, over here we got 8, 9, and then it would go to 2. Or sorry, then it would go to 1 inch at that point. So this right here on the main scale is 1 inch. Okay, we've zoomed in a long ways on it. Is everybody following me when I say that? Okay. So this is 1 inch. So it's divided into 10 parts. So this one here, what would it be as a decimal? What would this one be? And so on and so forth. So it's decimal values all the way up, or tenths of an inch. Okay? Now on our main scale on our micrometer yesterday, what did we split it into on the bottom side? we split it into 4 positions too. What was each of those worth? 0.25, I heard that. Right? Because we took 100 thou and we divided it into 1, 2, 3, 4 parts. Okay? So our main scale on this particular vernier scale is capable of measuring, this is the main scale on the top side, the vernier scale on the bottom. Okay? It is capable of measuring down to within, it has a discrimination of 0.025 or 25 thousandths of an inch. Okay? Again, this is my vernier scale down on the bottom. This is the 0 right here. Okay? So the 0 as it slides, that's where we read from. Okay? So this particular example, I'm just going to clear this off. Where are we reading from? We have 0.1. Okay? Am I 25 thousandths of an inch past that? No. So at that point, I want to know how far between these two I am. Okay? They've divided that into 25 parts for me. Okay, with their vernier scale. So this, if each one of these spaces is 25 thou, and I divide it into 25 parts, that means each one of these is going to give me a discrimination down to 0.001. Does that make sense? So, in this particular one, I'm 0.1. I'm not past any of the 25s here on my main scale again. Main scale, vernier scale down here. And if you need to, write that on and decide which one's which, right? It might help you decide what we're reading. So now I go along and I say which one lines up. I got this little X across there, it tells me that the 10 lines up. So therefore I add on 10 thousandths of an inch up there. Does that make sense? Okay, let's do another example. We'll scooch over to number 2 here. So again, on my main scale, it's the top one. I'm at 1 point. Again, I'm not past the 25 thousandths. So I just add on 16 thousandths, and you really got to watch that 0, that you don't just put 1.16. Does that make sense? Let's jump down to 4. Okay, so this one again, main scale, vernier scale. Okay, and don't be afraid to put that on these examples that we're doing so you can reference back to them. I am at 0 point because I'm somewhere before 1 inch, right? I'm looking at that one right there. Okay. I am at 0.3, right? I'm past the 3. Keep in mind that 3 would be right here. This would look something like that. Okay. So I'm 25, 50, 75 thou past the 0.3. So let's go 375. But I'm beyond that. This vernier scale now tells me exactly how many 25ths I am between that, and each one of those is 1/1000th of an inch. So what I can do is I can come in here, I can say, okay, it marked it there on that 15 thousandths of an inch over, so I need to add 0.15 onto that. 0, carry the 1, 9, 0.390. Any questions with that? I'm gonna leave you to those ones for a little bit, okay? The number 5, if you look at it, it's a 50 scale, okay? Which changes things up a little bit. Does everybody want me to do one example of a 50 scale?
Yeah.
Yes? Okay. That's perfect. We can do that. So, main scale on the top, vernier scale on the bottom. Okay. I am reading somewhere up before 1, so I'm 0. Okay. What am I at for decimal value there? I'm beyond the 8. Remember, these are tenths of an inch, so 0.8. Okay, now instead of dividing each of these tenths into 4 parts, they divided them into 2 parts. Okay, so the most accurate I can read on this main scale now is what? It's less accurate than those other examples. I can only read to within 50 thousandths of an inch. Okay, so if I'm beyond that, I would add 0.850, but I'm not beyond it. Okay, so I'm 0.800, and now I look down here and I look at which one lines up. Now I have an option of 0 to 50 to line up instead of 0 to 25. Okay, I go along here, it says 45, 46, 47 lines up. So therefore I am 0.847. Does that make sense? Okay. So you'll see different scales, different versions of it. The idea of how it works, the concept of how it works, the spacing of those numbers, one will always line up, and that's where we read. So we start on the vernier scale, or the main scale, get as tight a reading as we can there, and then we jump down and see which one lines up, and we add it on. We just have to make sure that our decimal place is in the right position when we do that. Does that make sense? Okay, so what I'm gonna do now, I'm gonna leave you to just go through a few of those examples, take a look at your settings. You can move it around, even your verns, okay, and say, what are you getting on this? I'm getting this. Just test yourselves back and forth, okay? So we'll probably lead into that for about 10-15 minutes here, probably 10 minutes or so, and then we'll do just a quick recap, and then that'll be it for the vernier scales. And we'll start getting into the measuring tool part A module, just to cover up the last few loose ends. Okay. Yeah, I like exactly what you did there, that's perfect. Yeah, draw in the rest of your line, especially on those ones that are kind of skewed off to one side or the other.
Yeah, because you got the fingers.
That one, yeah, so your 5 point, that's perfect. Any questions, Steve? Okay. You okay, Sienna?
So,
Yeah. It's gonna make sense, Georgia? Sort of? again, everybody else has a little bit more context to where we'll actually be using it, right, prior to this, but in any of the trades, measuring is more so. Automotive, heavy duty, or us, we're all gonna be
Okay. Question?
But yeah, I was just looking at the answers, cause
So this one should be left to be 2, right? This 0 is where we're reading off the main scale.
oh,
Does that make sense? 2, and then how far? 2, 5, 6, yeah.
I was just looking because this was right on this side of the 5 and 7.
Oh, yeah, that's just a.
Try those ones now, see if you can, so this is, just so everybody knows, okay? When you get to these ones here, this is actually a vernier scale off of a micrometer, okay? So I'll give you a few more minutes and then we'll run through a few of those if you wanna try them out. Or is everybody ready at this point? Everything run through those samples? Okay, let's go through a micrometer one then, okay? Sorry, I'm just gonna shuffle this back over here. So, we'll do a couple. I'll do one of these as an example, right here. Let's do number 3. Looks like a good one. Okay. So again, the components of it, again, still a vernier scale, but now this is what we're doing is we're reading down to within 1/10,000th of an inch. Okay, so again, just component wise, and we talked about this yesterday, this here is my sleeve back here. Okay, this is my index line, this is what I'm reading off of that sleeve. This over here, what's this piece called that has 25 divisions around it? Thimble, thank you. Okay, that's my thimble. And again, if you want to jot this down on your page right now so you can reference back to it, by all means. Okay. So without any of this up here, okay, what is this reading right now? Does anybody remember yesterday how to go about that? So again, we read from our main scale, and it was divided into, so we're going to be 0.1. Okay, we're past the 25, we're past the 50, we're past the 75. Okay, so I'm going to say 0.175 at this point. Now, how far past the 75 am I? It's split into 25 divisions. So it tells me that I am 14, 13, 12. I'm definitely past 12, but I'm not quite at 13. So I want to add 0.012 onto there. 12,000ths of an inch onto there. Everybody follow it? No? This is 14, 13, 12. Right? So I'm not quite at the 13, I'm 12 past the 75. Does that make sense now? Josh? Still no? Give me one. Maybe this will help. I'll have it set up like this. We just clear this off. So now we switched over to a real micrometer. Maybe it'll make a little more sense. Okay, Josh, you watching us? So we got our zero index line there. Okay, we've measured past 0.1, 0.125, 0.150, and 0.175. Right? So there we are at 0.175. Okay. Now what I need to do is I come up here 10, 11, 12, oh, sorry, I'm one down. I adjusted that. Right there. 11, 10, 11, 12, and I'm not quite at the 13. Does that make sense? Okay, so now I need to add on 0, 1, 3. So if I didn't have a vernier scale at this point, that's as accurate as I can really get at this point. No, 12.
Yeah.
Sorry, 12 I'm going to add on. I apologize. Okay. So I end up with a size right now of 0.197, but I do have a vernier scale.
871. 81.8.
Gosh, send me
On
home.
the same question.
Okay. So 0.187. Okay, thank you. Are you following along now, Josh? Okay. So this is what it really looks like. And now here you can see this vernier scale up the top side. Now, this is laid out just a little bit different than the other one. And that's what I'm trying to get at, is that we have to work our way through, because each measuring tool we come across could be slightly different. This one, I can actually read, this one actually is split into 50 divisions all the way around my thimble. So I can actually measure down to within a half thou just off of it. Okay? So it tells me that I'm actually above the half thou mark, and then I would go up and look and see which one of these lines up. Okay? So in this particular setup, I'll see if I can do it. I'm just going to lock it into place right there, and then we'll jump back to number 3 and figure it out. But this gives you a kind of a practical application of where you'll see it. So now what I'm going to do is I'm going to pick this up. I'm going to try not to shake too bad for you. And you'll see as I roll it around, so there the 2 lines up, there the 3 is just barely, and the 4 and the 5 don't line up. Okay? The 1 almost lines up, and the 3 almost line up, but the 2 definitely lines up. Does everybody see that? So now what I'm going to do is I'm going to add that on. So I was actually 187, and because I was past that half mark, I was actually 187.5. And now what I'm going to do is add on another 3 10,000ths of an inch, 0.0003, and we end up with 0.1878. Again, it just rounded up for me there, 188. On this particular mic, it's got a dial in it, which is kind of cool. Okay. So let's jump back over to question 3. Everybody following along at this point? Did that clear things up at all, Josh?
A little bit, yeah.
A little bit? Get this out. Get question 3 down in here. So, let's look at this one again. 100, 0.1. Okay. Past the 75 thousandths mark, that's all I can get on my main scale. Now I'm going to go over to my thimble. I'm going to read what it's reading. And again, I am at 12 thousandths of an inch. 1, 2. Okay, so I can do that math right now if I want. 187. And now how far between that line am I? Well, let's go to the vernier scale and it's going to show that to me. Then I come up here and I look along, and let's do it. I would say it's either the 5 or the 6. Maybe, let's say, closer on the 5. Everybody happy with that? So now I add that 5/10,000ths of an inch on there. So that's how we accurately measure down to within a 10,000ths of an inch. Okay. Any questions with that? No? So that'll get you through, practice a couple of those. If you've got questions, I'll go through them one-on-one with you. Go through a couple more of those examples. The next page goes back to some other types of vernier scales. So keep rolling through some of these pages and keep practicing. Okay?
Ignoring denominations. Right, it's just like
406.
And then whichever one lines up 5. Right, 7 is that one?
just this.
6. So you gotta just think about where you are going through them. You passed the 6, but you haven't got to the 7 yet.
Does that make sense? Going okay? You guys doing okay? Going okay, Jen? So what's gonna happen with that is it's tricky to draw this and photograph and have an image that actually looks right. So what they do is when they unroll it all, it kind of skews a little bit. So you're absolutely right. You wouldn't think that down here you're kind of somewhere in the middle. They put it in the middle there so that you're not guessing if you're above or below. It's definitive that line is between. Okay, that's just kind of what it is. So yes, in all reality, you would look at that when you're actually using a mic, but when we're doing this, you just kind of say, well, you know, in between those two. Now let's see what happens. Okay? You got it. Going okay with it? Any questions? Think you're getting it? Any questions on the particular one? Yeah, okay. Again, that's a metric, right? Yeah, perfect, good.
Try one.
Walk through one with you?
So on the main scale, students are divided into
That is a four.
but instead of kids that we divided it into 16, we just divided it into 10. So that's what this, the 1, 2, 3, or 4, is usually one.
I don't know what plan before, but they do all the same every time. So you just roll this thing. I don't know how to do it now. You're dead. You're dead.
1 inch divided it into.
It's like someone's like, I remember I was back around, and then it's around those. They said that. You're dead. Why would you do that? Let's see what you do.
It's 75 now. Past 3 of those, so we can say 0.478. So does that make sense? So for, this is kind of, this line coming down is where we start to measure the two base things. Measure that tape measure along here, wherever we're measuring to, that's where that is. So now we are 475, so that's as much as we can read off the main scale. This pinball we gotta rotate around the outside. When we get in, it's divided into 25 equals. Every one of those will be divided in threads of 1,000. So we take that 1 inch, and this, that's the thickness that that one is.
Or it's not metric, right?
So kind of a bit of reference. So now this is, you can't pass the 75, how far past it would come?
No, it's not.
We were actually going to pass 18, 17. So let's add 18 now. And now, with this one, we can even read to the 10,000 something, right? So then astronomically small, no variation. So then we come up and we decide which one of these lines up. I would say probably we're gonna have 10,000 something, so we're 4 decimal place.
Oh, that's.
Here's the back model.
Now it's 0.0008. Which line would be together, and it'd be 475 plus 18 is 493, sorry. That's how we divided it. So, yeah, it's, you got thrown to the wolves right away, right, going right to the very end of it, but, yeah. It's one of those things as we go through and we practice, and that's what it comes down to, practice. Any other questions? How's everybody doing? You want a few more minutes to work on this? Are you doing okay with it? Want to look at it at home? What do you figure? Seeing some thumbs up. So yeah, just a quick recap. How do we go about it? What are the different components of my verns? So again, the different components, how they work. The big thing when we're starting to learn how to read is which is the main scale, which is the vernier scale. Okay? What's the order that we read them in? Main first. So we read that main scale first. We get as tight of measurement as we possibly can off of it, just like a tape measure. We read from the 0 on our vernier scale. That's where we get that initial measurement from. Okay? After that, what do? And we jump down and we look at that vernier scale and we say which one lines up.
what size is that value, and usually it's going to tell us, in this case, right? 5/10 of, 5/100ths of a millimeter, okay? And then we can verify and add it up, and we get our dimension and our size, okay? Comes down to practice. So practice this, the worksheet I gave you. Make sure you're understanding it. If you have questions, specific ones, if you want to verify some sizes, let me know. And then next week we'll actually get out into the shop and we'll be able to start measuring and actually getting our hands on the tools and utilizing them, and actually start to get that feel as well for them as we go. Okay. So any questions before we go? Or before I wrap this part up anyways? Okay. Go.